Hello everyone. Today let's solve the problem number 494, target sum. So what the question states here, we are given an integer array nums. You can clearly see here we are given an integer array nums and a target integer target. You can clearly see here we have integer array nums as well as the target integer target. So our main goal is to add either positive or the negative before each number and nums. Positive or negative means plus or minus symbol, right? So our goal is to add either plus or minus before each number in nums and concatenate them to form an expression that evaluates to the target. So by making use of plus or by making use of minus, we have to calculate the sum that is present in the nums to sum up to target here. This one has to sum up to the target. In this case, it has to sum up to the target 3 by making use of these elements, the elements present in the nums array, right? So we need to determine the number of valid expressions. So the number of valid expressions we need to determine here. You can clearly see here 1, 2, 3, 4, 5 like that. So there are 5 ways to assign symbols to make the sum of nums to be target 3. Here you can see minus plus 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 minus plus plus plus, like that they have continued 3 more times, right? Yeah, plus plus minus plus 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 negative, this one positive again, plus 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 finally this one minus here. This will also lead to the sum of 3. Everything leads to the sum 3, right? Nothing but the target. Everything sums up to the target. So that's what we need to do here. Same thing goes with the example 2 as well. Here we have only one element. Target is also 1. So we can just return 1 here in this case. So that's what they have shown here, right? So I hope the question is completely clear, right? I hope the question is completely clear and how what we need to do here. I hope this is completely clear. Initially, let's discuss the approach step by step, followed by edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. As usual, initially, let's discuss the approach. Let's start discussing the approach step by step. I have considered the first example that they have given in the question. Same example I have considered here. So target is 3. They have given target 3. Number of elements, this one 5 we have, 5 ones we have, right? So output we have been given 5. These are the ways they have said, right? We have already seen this one. So let's discuss how can we solve this one, right? So first thing we need to keep in mind here is we will be making use of dynamic programming here. So just keep this in mind. We'll be making use of dynamic programming here. This we'll be making use of 2D DP or dynamic programming, right? So just keep in mind we'll be going with 2D dynamic programming here. So the first step here is the base case, right? So first, before the base case, so we will construct the DP table step by step, right? First thing, we will define table. So dp of ij here represents 2D dp. This is 2D, 2 dimension, right? So we are going with the dp of ij here, right? dp of ij represents the number of ways to get sum j using the first I numbers, right? So let's initialize the dp table first. We will create the dp of n plus 1 and s plus 1. So here in this case we'll be going with dp of n plus 1 plus dp of s plus 1 for easy computation, as we are dealing with the 2D dp. So where n equals 5, right? So and s equals 4 here in this case. N equals 5 and s equals 4 in this case, because we are going with n plus 1 and s plus 1. N equals 5 and s equals 4. And base case here is, let's start this one. Let's start with the base case initially. So dp of 0, 0 is always 1. Why it is always 1? Because there is only one way to form 0 initially. 0. There is only one way to form 0 by picking nothing. dp of 0, 0 is always 1, right? So let's fill the table initially with 1. So this one, let me come here. This one is 1 and all other things are 0 here, right? I hope this is clear, right? So next thing here is we will find the DP table using the recurrence relation. So this is the formula we will be going with. Just keep this in mind. This is the formula we will be going with, or we will find the DP table. All other cells we have to fill all other cells in the table here, right? So we will be doing that using the recurrence relation. This is the formula. DP of ij equals DP of I minus j plus DP of I minus 1 into j minus nums of I minus 1. This is the relation that we'll be going with. I hope this is completely clear, right? This is the step-by-step calculation of DP table we'll be doing, right? So the first case here is we have base case, we have already filled this one. DP of 0, 0 is 1 because there is exactly one way to get the sum 0 by picking nothing. We know this one, right? All other values in the row remains 0. Here you can clearly see, right? So this is first thing. And let's come to row 1. Here nums of 0 is always 1, or DP of 1, 0 is 1 here. Why DP of 1, 0 is 1 here? Because there is one way to get sum 0 by not picking 1, right? Also by picking 1, we can pick 1, or by not picking 1. There are two ways. So here for 1 comma 0 it will be 1, and for 1 comma 1 also it will be 1. For 1 comma 1 it is equals 1 because we are picking 1 here. In this case we are picking 1. In this case we are not picking 1. One way to get sum 0 by not picking 1, right? So there is one way to pick 1 here. So this will be 1. All other cells will be in this row will be 0. I hope this is clear. Let's come to row 2 here. Here nums of 1 will be initially 1, right? Nums of 1 is 1. So here let's calculate DP of 2 comma 0. DP of 2 comma 0 is 1 here. Why? Because there is always one way to form 0. We know this one, right? So this will be 0. So this will be 1. So here for this one also this will be 1, 1 and 1. Let's go step by step. So DP of 2, 1, this one, the next cell, DP of 2, 1 is DP of 1, 1 plus DP of 1, 0. 1, 1 plus this one, 1, 1 plus 1, 0. This will be equals to 1 plus 1, nothing but 2 here in this case, right? So DP of 2, 2, let's move to the next cell. This is DP of 1, 2, this one, DP of 1, 2 plus DP of 1, 1, this one again, 0 plus 1 will be 1, right? So all other cells will be 0 here in this case, right? Let's move to the row 3 when nums of 2 equals 1. So nums of 2 will be 1 here. DP of 3, 0 will be 1 as well initially. So DP of 3, 2 is DP of 2, 2 plus DP of 2, 1. This one, DP of 2, 2 plus DP of 2, 1. We are going with the recurrence, this one relation. We are going with this formula. So if you don't know what we are doing, just for the sake I'm telling. So here DP of 3 comma 1 is DP of 2 comma 1. DP of 2 comma 1 plus DP of 2 comma 0. 2 plus 1 here, this will lead to 3. This one, 2 comma 1 plus 2 comma 0. This will lead to 3 here, right? So this is fair. Next DP of 3, 2 is DP of 2, 2 again. DP of 2, 2 plus DP of 2 comma 1. This will be 1 plus 2 again. It will be 3 here in this case. For this one DP of 3, 3 is DP of 2 comma 3 plus DP of this one 2 comma 2, this one. So we will go with 0 plus 1 is 1. Next all other cells will be 0. In this case we have only one cell, this will be 0, right? So let's move on with the row 4. DP of 4, nums of 3 is 1. So initially nums of 3 is 1 here. This one DP of 4 comma 0 is initially 1. DP of 4 comma 1 is nothing but here DP of 3 comma 1 plus 3 comma 0 here. This one 3 comma 1 plus 3 comma 0. 3 plus 4 is 4 here. 3 plus 1 is 4 here, right? So DP of 4 comma 2 here. This one, let's move to the next column here. DP of 4 comma 2 here is DP of 3 comma 2 plus 3 comma 1. 3 plus 3 here. In this case it will be 6. DP of 4 comma 3 will be DP of 3 comma 3 and 3 comma 2 here. 1 plus 3 will be 4 here. Finally DP of next cell 4 comma 4 is DP of 3 comma 4 and 3 comma 3. 0 plus 1 here is 1 in this case. So we have filled all the cells in the row 4. Next go with the row 1 is finished, row 2 is finished, 3 is also finished, 0 is also finished, row 4 here, dp of 4 also we have finished. So last one, dp of this one, row 5, nums of 4 equals 1 initially. So here this will be 1. dp of 5 and 1 is dp of 4 comma 1 and dp of 4 comma 0. This one, dp of 4 comma 1 and 4 comma 0, this is nothing but 4 plus 1 is nothing but 5 here in this case, right? So dp of 5 to next cell, this one, dp of 5 to here is nothing but dp of 4 2 plus dp of 4 1. 4 2 plus 4 1 will be this one and this one. 6 plus 4, this will be 10 in this case. dp of 5 3, next cell we are moving. dp of 5 3 here is dp of 4 3 plus dp of 4 2. 4 3 plus 4 2 is nothing but this one and this one. 6 plus 4 again 10. So final this one, final cell we have to calculate, and this itself we will return as output, right? So this itself we will be returning as output. Just keep this in mind. This one itself we have to return as output. So dp of 5 comma 4 is nothing but dp of 4 4 plus dp of 4 3. dp of 4 4 is 1 and dp of 4 3 is 4. 4 plus 1 is here 5 in this case. So in this case output is 5. You can clearly see the final answer here is, so the final answer here is, so as I have said, dp of 5 comma 4. Let me come here, just give me a second here. This one, this one, last cell in the table, right? So this will be dp of 5 comma 4, that we got 5. That's what we need to return. dp of 5 comma 4 is nothing but here in this case 5. I hope the approach is completely clear. So the output will be, in this case it will be 5, right? So we will return 5, right? So I hope the approach is completely clear. Let's discuss the edge case step by edge cases step by. So the first edge case that we'll be going with here is smallest input. So nums, we have only one element, smallest input size we have considered. Target is 1. So the output will be quite obviously 1 here, plus 1, right? We can consider only this one. So this will be 1 here. So the second edge case that we'll be going with here is this one, no possible expression, right here. No possible expression means the maximum possible sum here will be 1 plus 2 plus 3, in this case 6, right? So we can never reach 7 at all here in this case. Even if we give negative, positive, anything, positive, negative means plus minus sign, we can make use of anything, but we will never reach 7 in this case, right? So the output will be 0 in this case for the second edge case. So the third edge case that we'll be considering here is all zeros. All zeros means each zero have either positive, this one, plus or minus, but results in the same sum. Target is given 0 here, right? So there are 2 to the power of 5 ways, nothing but here in this case there is 2 to the power of 5 ways, nothing but 32 ways, right? So to assign positive, this one, plus or minus to 5 zeros, either we can go with plus or minus. So again I'm telling, each zero can have plus or minus, but results in the same sum, nothing but 0. But we have how many ways we have, that we need to return, right? So there are here 2 to the power of 5 ways, 5 ways, right? So it will be 32 ways to assign plus or minus to 5 zeros. This will be 32 in this case. I hope this is clear why it is 32. So let's move on with the fourth edge case, nothing but here large target with large values. So we have considered target 1000 and the nums 100, 200, 300 and 400 here within the nums array. So maximum sum here is this one, in this case 100 plus 200 plus 300 plus 400. In this case maximum sum here is 1000. So the only way to get 1000 here is this one, 100 plus 200 plus 300 plus 400, right? So the output will be in this case 1. So the final edge case is negative target. When I say negative target, we'll go with the minus 4, right? So we are going with the negative target here. So possible expressions here is there are we can just go with for the minus 4 it will be minus 2 plus 3 minus 5. This will be minus 4. So there is only one way. So you can just try out all the possible combinations, but this is the only way to get minus 4. This will be minus 1. You can just check out in the same way that I did for. If you want to compute in the form of DP table, I have done that one by considering example 1 in the approach, right? So we discussed that one step by step. If you can do it in the same way for this one as well, if you want to understand clearly, right? So this will be 1 in this case. I hope all the edge cases are clear here. So the first edge case that we went with here is minimum input size. The second edge case that we went with here is target is 0. The third edge case that we went with here is all zeros. The fourth edge case that we went with here is large target with large values, and the final edge case was here this one, negative target. So these are the 5 edge cases that we need to consider. So next what we will do, we will start writing the here initially what I'll do, I'll just initialize into length of the nums. So we'll be making use of the length of the nums several times. So I'll just assign this one to the variable n here, right? So sum equals, we need the sum. We saw that one, right? For every cell we need to calculate based on the this one recurrence relation. So sum variable I'll just make use of here, and I'll just give you nums dot reduce. And this case I'll just consider two variables a comma b. This will be, as we are going with the addition, this will be a plus b, and the initial value we need to give in the reduce nothing but 0. This is fine. So the first thing, or the the first thing we need to consider here is if sum plus target is odd or target is out of range, then we have to return 0. We have considered this one, right? While explaining the question itself, I have said if sum plus target is odd or target is out of range, we have to return 0 in that case. So let me make use of the simple if condition here. This is let me give you sum plus target, this one if it is odd. So this one I can just give you modulus of 2, modulo 2 here. This one sum less than, I'll just make use of math dot absolute, right? I can just give you abs of target here. This is fine. So then what we will do, we have to return 0 in that case. So just give me a second here. Did I miss anything here? Alright. So here the bracket. So this one I'll just remove. This one we have given here, right, after the target. So we have to just return 0 in that case. So if sum plus target is odd or if target is out of range, then we have to return 0. Next one, we require the subset sum, right? So let's go with the required subset sum. So we can just articulate that one in the form of code in this way: s equals sum plus target. This is fine. So target by 2. This is fine. The next step is we will be making use of the DP table. We know this one, right? We are going with the approach dynamic programming. So we'll be making use of the 2D DP table. Let me assign DP2. This will be array of n plus 1 dot fill here. This one will be map. This one is in here, map array of s plus 1. This is fine. Again, let's fill this one with 0. This is fine. So this is the DP table will be. So we have initialized the DP table here. We are going with the 2D DP table. Here you can clearly see array of n plus 1 and array of s plus 1, and we are initializing initially with we are filling that one initially with zeros, right? So I hope this is completely clear. The base case, what is the base case that we had discussed? So there was there is only one way to make sum 0 by choosing nothing. This we know. So I can just articulate this one in the form of code like this: dp of 0 0 1 equals 1, right? So let's iterate over all the elements in the nums quickly. So as we are going with the 2D DP table, we need two for loops here, right? For let I equals 1, I less than or equal to n. Let's increment the I. Same goes with the j as well. So I'll just consider here for let j equals 0, j less than or equal to s, and let's increment the j here. So within the for loop, we have to consider when we don't pick nums of I plus 1 and when we pick nums of I plus 1. We have discussed this one as well, right? So this is when we don't pick nums of I minus 1. So I can write this one in this way: dp of ij, this is equals to dp of I minus 1 here j, right? So this is when we don't pick nums of I minus 1. So there is also a case when we pick nums of I minus 1. So we have to ensure in that case j greater than or equal to nums of I minus 1, right? So I said there are two cases: when we don't pick nums of I minus 1 and when we pick nums of I minus 1. So this is for when we don't pick nums of I minus 1. Next, what we have to write for? We have to write for the case when we pick nums of I minus 1, right? So what we need to ensure when we pick nums of I minus 1? J greater than or equals to nums of I minus 1. So simple if condition here: if j greater than or equals to nums of I minus 1 here in this case. So what we will do, dp of I j here, this is dp of ij equals dp of I j plus dp of I minus 1 j minus nums of I minus 1. This is fine. I hope this is clear. So the final step here is we have to return the number of ways to form the subset sum. Yes, that's what they have asked in the question, right? So let's return the number of ways to form subset sum is nothing but in this case dp of ns, right? So I can just write in this way: dp return dp of n and s within the array. So this is it. Let me format the code once and let me hit the run button. Let's see whether this works or not. So you can clearly see here the sample test cases are getting passed. So let me quickly hit the submit button. So you can clearly see here all the test cases are getting passed here. So the code works absolutely correct in this case. So let's quickly discuss the complexities of the code that we have written. So the approach that we went with here is dynamic programming. We know that one. So what would be the time complexity here? The time complexity, overall time complexity would be n into sum. So sum, this one, somewhere we have considered this one, right? N into sum here. And what will be the space complexity here? The overall space complexity would be n into sum as well. Just give me a second here. Yeah, the overall space complexity would be a big of n into sum as well, because it can be optimized to big of sum here by making use of a 1D DP array, but we have made use of the 2D DP array, right? So this is fine. I hope this is completely clear. So the time complexity here would be big of n into sum, and space complexity would be here big of n into sum as well, right? So I hope the solution or the code that we have written is completely clear. For now, this is it. Thanks for watching, guys.